Hello, in this video I'm going to show you how I've made a triple turn indicators for my car. It's a real simple but useful feature which allows you to just tap the signal stalk once and the turn signal lights will flash 3 or 5 times depending on the system settings. And I find it very handy, especially for line changing on highways or when exiting roundabouts. This is maybe one of my favorite little features. But for some reason, people who designed electronics in my car decided not to add it or simply forgot about it. I mean, this car has a dual zone climate control, heated seats, reverse camera, auto lights and many other options. Some of them I've never used but lacks such a simple one as triple turn indicator. So I decided to make my own. But before we start, let's discuss how cars' turn indicators work. Well, there are a few different designs, depends on the generation and car manufacturer. In old cars it can be a thermal flasher relay, comprised of a coil and a piece of curved metal band. When you engage turn indicator, current goes through the coil, it heats up that metal band, and when it's getting hot, it pops and opens electrical contacts. Afterward, it cools down and obtains its initial shape, which again results in closed electrical loop, and that process repeats on and on. In modern cars though, that kind of thermal relay is replaced with something called turn signal flasher assembly. Or it also can be a body domain controller, or even or it might be one of the many functions of BCM, body control module. Well, basically whatever it is, it's important to understand that there is something that makes turn lights flash. Let's call it a flasher relay. Now, how does it work? So when the indicator stalk is pressed up or down, meaning we're about to turn left or right, it sends a constant signal to the flasher relay. And flasher relay operates turn lights by generating repetitive signal. So my goal was to maintain that constant signal from stalk to flasher relay for some time after an indicator stalk was just slightly pushed up or down and doesn't stay in that condition. And to do so, I'm gonna build a circuit based on 555 timer in monostable mode. The 555 is an extremely useful IC made up of numerous transistors and resistors, as we can see on this diagram. But it all can be simplified into block diagram, which is much easier to comprehend. There are 2 transistors, 2 comparators, a flip-flop, inverter, and a voltage divider. The voltage divider is made of 5 kilo ohms resistors, and this is probably why it's called 555 timer. In monostable mode, the 555, when triggered, outputs a stable electrical signal for a certain period of time, and the time that signal stays on depends on the values of a resistor and capacitor connected to the 555. I probably should say that this video is not a tutorial on the 555 timer itself, it rather very briefly describes how this IC operates in monostable mode, so don't worry if you feel a little bit lost right now, it all will become more clear towards the end of the video. Okay, let's get back to our circuit. As long as this capacitor has no charge, the output will be off, even though the circuit is connected to power, because the negative inputs of both comparators have a larger voltage, so they both output low and the flip-flop outputs high, so the transistor is open, connecting the capacitor to ground through the discharge pin. But when our trigger pin is shortly connected to ground and comparator 1 outputs high, setting the flip-flop, now the timer outputs high even after pin 2 is not anymore connected to the ground. Because the transistor has been turned off, disconnecting capacitor from the ground, so it connects to VCC and charges up. Once the capacitor has a charge higher than 2/3 of VCC, the positive input becomes predominant and comparator 2 outputs high, turning on the transistor and causing our timer to output low. And with the transistor on, the capacitor discharging back to 0, and the entire circuit will stay in this state until pin 2 is triggered again. Now let's set up the circuit in real life. You don't have to follow along as I'm doing it. This is exactly the same circuit as in this diagram. I'm going to connect a little LED to the output of the 555 timer for better visualization. As pin 2 gets triggered, you can see that LED stays on for some time before it turns off, and this is exactly what we need for our purpose. Only we probably might want to decrease the value of that resistor so the output signal stays high for a shorter time, giving us about 3 or 4 flashes of the turn signal. You may also consider to use these trigger delay relays. They're really cheap, and this is basically the same setup, only with neat implementation. I'm going to use 2 of these, one for each side. Here you can see how it works with only left indicator connected to our circuit board. Later I connected the right side as well and adjusted resistor so that it flashes exactly 3 times. Okay, I hope you enjoyed that video and I see you next time. Bye.